Hello class, let's proceed with the second part of procedure number 1. So that was the first part. The second part tells us to measure volume of certain amount of liquid, using our 3 beakers. Okay, so we have 3 beakers, beaker 1, 2, and 3. So this is a 50 ml it has a 50 ml capacity or 50 ml capacity beakers. So we'll see. I'll fill in these beakers with 50 ml water, 3 of which using our standard liquid measuring device, our graduated cylinder. Okay, it's 50 ml. I put it on the beaker 1. Okay. I'll measure another 50 ml. Okay, I'll put it on beaker 2. I'll fill this up again with 50 ml. Okay. And now I'll place it on the third beaker, beaker number 3. Okay. Now, try to note the volume reading. Does it coincide with the 50 ml mark? Okay. See for yourself. So this is beaker 1. This is beaker 2, and this is beaker 3. Almost the same reading since we are using standardized glasswares. So more or less, no, they have the same reading. 50 ml from the graduated cylinder, and for the 3 beakers, more or less we cannot really see an appreciable discrepancy. So it's almost the same. Okay, try to make your observation and record the data. Now let's proceed to procedure number 2. So that's how we measure volume of liquids, such as water. So we have done our practice already. Now let's try to do another volume measurement. But this time, I will be performing, or my objective is to measure the volume of this pebble here, or small rock. So, if you are to measure the volume of this irregularly shaped solid by itself, you'll be needing a great amount of mathematics for this. From integral calculus up to differential equation, just to ascertain the volume of this irregularly shaped solid. And that is very cumbersome to do. But don't worry, there is a very efficient way of determining the volume of this irregularly shaped solid. If the solid is regularly shaped, then the volume can be measured using some geometrical formulas, like how do we measure the volume of irregularly shaped solids, like a rectangle, a square. So all you need to do is measure the length, the width, and the height, multiply them together. Or for triangle, for pyramids, di ba, mga 3-dimensional objects or shapes, There are certain geometrical formulas to use. But for irregularly shaped solid, as what I've said, it's very cumbersome to compute that mathematically. But don't worry, we have a very simple way of measuring the volume of irregularly shaped solids, and we call this water displacement method. For water displacement, again, we'll be needing a beaker, a graduated cylinder. Again, I will fill this up with 30 ml water. Yan, 30 ml. Okay, there you go. 30 ml. Then, I'm reading from I'm trying to be very accurate this time. So if you could notice, based on the lower meniscus mark, okay, 30 ml. So that is our initial volume. Now, I will add in the P-ball to ensure not to splash the liquid out of the container or the graduated cylinder, and also to protect the glass container. So I will insert this P-ball in a slanting position slowly. Okay, there we go. Now try to see the increased level of water inside the graduated cylinder and call that the final volume. Okay, reading from the lower meniscus, I can see from here that it is now at 40 ml mark. To do that, try to read the procedure and record the data. Initial reading, 30 ml. Now, our final reading is 40 ml. Try to do a very simple arithmetic and you will know the volume of the P-ball inserted into this graduated cylinder. So that ends procedure number 2. Now let's proceed to procedure number 3.